Okay, so solve 4x to the 5th minus 100, and x is raised to the 13 thirds equals 0. So I want to point out a couple of things first. Note. 5 can be written as 5 over 1, and you can try to find a common denominator. If you look at the other power here, it has a denominator of 3. So you can multiply the top and the bottom by 3. That way you're multiplying by a fancy number 1. So this is the same thing as 15 thirds. So we're going to factor out the greatest common factor. Which we also call the GCF. Okay, so look at just the numbers, the 4 and the 100. Well, we see that 4 is a factor of 100, so we can factor out a 4. And then we're always going to factor out the smallest power of x that's in both. Okay, so as you see, we have 15 thirds and we have 13 thirds. So which one is smaller? Well, the 13 thirds. So we're going to factor out 4x to the 13 thirds. Okay, and then we're going to open a set of parentheses and put some stuff in here so that when we distribute again, we get the original. Okay, that's our strategy. Okay, so we know we have 4x to the 5th, which, let me write it again, was 4x to the 15 thirds, if I want to put it in terms of that denominator. Okay, so there's going to be right here, we're going to have x to some power. Right now I'm going to call it m. So I know that I'm going to need to distribute this back, and this product is going to be need to be 4x to the 15 thirds. 4 times x to the 15 thirds. So if I had 4x to the 13 thirds times x to the m, common bases multiplied together, we add the powers. So the new power would be x to the 13 thirds plus m. And I need it to be 15 thirds. So I'm solving this equation. 13 thirds plus m equals 15 thirds. Well, if you solve for m, you can subtract 13 thirds from both sides. So m would be 2 thirds. Does that make sense? So let me put a 2 thirds right here. So this is 2 thirds. So if we distribute 4x to the 13 thirds times x to the 2 thirds. So 4x to the 13 thirds times x to the 2 thirds. Common bases multiplied together, we add the powers. This is 4x to the 13 thirds plus 2 thirds, which is 15 thirds. Okay? And then we say, well, 4x to the 13 thirds times what gives me negative 100 times x to the 13 thirds. Well, we have a 4 right here, so 4 times what is 100? Well, 25. And we already have all of the x's we need. We have x to the 13 thirds. There's x to the 13 thirds. Okay, then we're going to remember that we have this zero factor theorem. If a times b is 0, then one of the pieces is 0. Either a is 0 or b is 0. So 4x to the 13 thirds equals 0, or x to the 2 thirds minus 25 equals 0. If we solve this first one, we can divide both sides by 4. So x to the 13 thirds equals 0. Well, but keep in mind, 0 to any non-zero power is still 0. Like I said, as long as m is not 0. So that means x is 0. You could also raise both sides to the power of 3 over 13. But this is easy enough just to say, well, if 0 to some power is going to be 0. Okay? And then over here we say, well, x to the 2 thirds equals 25. We're going to try to get this power to be a 1. We need x to the first power. So we're going to undo it in pieces. So one thing we can do is multiply, raise both sides to the 1/2 power, which is the same as multiplying by 1/2 for the powers. Because a power raised to a power, we multiply. So we would get x to the 2 over 3 times 1 over 2. So that's x to the 1/3 equals, well, 25 to the 1/2 is 5. But we have to be really careful. This is the same thing as having this equation and taking the square root of both sides. But we remember when we take the square root of both sides, we have to put a plus or minus. So this is really plus or minus 5. Okay? Because the square root of 25 is 5, but you have the plus or minus. So x to the 1/3 equals either plus 5 or minus 5. Now we're going to raised to a power again, so that the new power of x is a 1. So if I raise both sides to a 3, power raised to a power of x to the 1/3 times 3 over 1, I get x. So x equals 5 cubed, or x equals negative 5 cubed. So positive 125 or negative 125. Okay, but now we have to check our answers because we raised both sides of the equation to a power larger than 1. So we must check our answers to make sure they work. Okay, so we go back to the original. What was the original? 4x to the 5th minus 100x to the 13/3. Okay, so 4x to the 5th minus 100x to the 13/3. Is that equal to 0? If I plug in 0. 0 minus 0, is that equal to 0? Yes. Because 4 times 0 is 0. 0 to any power is 0. That one's the easy one. Now let's check x equal positive 125, excuse me. So 4, and then I have 125 to the 5th minus 100 times 125. I'm going to make it smaller first, 1/3 into the 13th. Is that equal to 0? I have to use my calculator here. That's really big. Let's see. So I'm going to write it down. 4 times 305,175. Let's choose 305,175,78125 minus 100 times, okay, then we're going to have 5 to the 13th. Is that equal to 0? And you type that in a calculator. Let's see, minus 100. And yes, it is equal to 0. So that one works. Okay, and then we check x equal negative 125. You're going to see that that one will also work. 4 and then negative 125 to the 5th minus 100. Then we have negative 125 to the 1/3, and then that's raised to the 13th. Is that equal to 0? So when you have a negative number raised to the 5th power, your answer is negative. So it's going to be the same as this, but the sign is going to be opposite. And the same thing here, the sign is going to be opposite. So you're really going to be subtracting these in the other order. You can check it, type it in the calculator, but that one's going to work too. So these are your 3 answers. X equals 0, x equal 125, and x equal negative 125. Okay? So our strategy again was to try to factor out the greatest common factor, set each piece equal to 0, solve, and then we had to check.